Okay, so we have our first model, and in the last video we came up with the absolute differences and the sum. And now we're going to go at this a little bit of a different way and see if we can get a better one. So how should we proceed? Instead of standard form, what would be another way we could do this?
Looking at this, we don't have our two roots, so putting it into factored form would be difficult for us right now. But we could make a good call at where our vertex is on our data points.
What do you think?
That
I'm moving with the little x here. You tell me left, right, up, down.
I would say that's pretty much where we are, isn't it?
Okay, so if you see at the bottom there, where are we at? Minus 70 and 73?
Yep.
Okay, so now we're going to go into, what are we happy with this? We've got A, B, and C. The y-intercept is sort of useless to us based on this.
Yep.
The B doesn't really tell us much, but what about the A? Do we like that, or do we think we could change it?
So the A is all about this stretch, isn't it?
Mm-hmm.
So if we're looking at this, it looks as though it's fitting the data fairly nicely, I would say.
Should we keep it?
Yeah, we certainly need to start with, I think.
Okay, so now we are analyzing curve fit, but we need to define this. A, bracket, and then x minus h,
Yep.
and we decided that was going to be...
That was our minus 70, so we actually need a plus 70 here.
Okay, now we're squared, and...
We are adding 73.
Okay, and A was negative 0...
0.015, I think it was.
0.015. It's so confusing when to use decimal and when to use comma, but in Logopro we need the period as the decimal point, right?
Yep.
Okay, let's call it quadratic vertex so we can distinct, and we want to make sure we're on manual. Okay. Ooh.
That looks pretty good.
That does look pretty good. Okay, there we go. It looks a little clunky on the screen there, but that's kind of a nice screenshot, isn't it?
It is, because it shows both models on there.
Mm-hmm. So, then let's take this guy off for a second, and what do we think?
It looks pretty good. It's not a perfect fit, and it would be very hard to get a perfect fit because real life gets in the way sometimes.
Perfect. Okay, then let's take this and carry on with our analysis. Okay. And now we have our second model, and that is y equals negative 0.
Comma 0.015.
0.015 x squared.
So we need our vertex form this time, don't we?
Sorry, that was comma x
plus 70.
Shifted left.
And then we're adding 73.
And there's our vertex. Now we can be a bit forgiving in the Excel here, right? With that hat, but when they're getting it into their project, we don't want to see that.
Yeah, and so when we're writing up a report, we'd use math type, wouldn't we?
Excellent. Okay, so equals, now this is going to be negative 0, I need the comma again, times, and I go all the way over here.
Do we need our brackets still?
Oh my goodness, I'm terrible on my brackets today. There we go. Okay, and
plus 70.
Thank you.
And then with our hat. And then 73. Perfect.
So we can take this guy. Okay. So there's our second model. These are now the values of these black lines. Or the height of the black curves, it's not a line. All right. And you notice these are closer than our original one, aren't
it? It certainly looks like it, but we can actually mathematically compare them now, can't we?
Okay. So we go through this again. And which two cells are we comparing?
So we're still looking at the actual ball height, so that's our B column. And now we're looking at the second model value.
Perfect.
So just on this first one, we can see that difference is a lot less than before.
So here it was 3.26,
Yeah.
and here it's 0.27.
Okay, so it'll be interesting to see now if we sum up these, how they compare.
Okay, equals sum, select, then I hit shift and select the bottom one, close the bracket and enter. Ooh,
That's a lot less, isn't it?
that is. There was one word that we forgot on the last video. This is the sum of the absolute differences, but in the project checklist it says something else.
Yeah, so it actually says the absolute mean difference, I think, doesn't it?
Okay,
So the mean is, on average, how far is each point away from the curve. So in order to find our mean, we need to add up all the values and then divide by the number of data points that we've got.
okay, so how many data points did we use?
So is that 16 now?
16. Excellent. And let's do it for this one. We can be nearly, well, we can be 100% sure that we have, excellent, good. So this number is, we nearly halved it, didn't we?
We did, yeah. That's
Okay.
a pretty good improvement.
It is. So that's the number you can compare and justify that your second model is better than your first. If you do a video, you get quite a few points. The spreadsheet can handle them equally as well.
Yeah.
If they have used a photo, are they likely to have 16 points?
Probably not, but they should, I would say, a minimum of 5 points used to collect their data.
All right.
Yeah.
So we used a new form of the vertex, of the model. We got it closer, thinking about our transformations, and we mathematically justified the improved model is indeed better.
So which of those models would you use then to answer your prediction question?
Oh, I would definitely be using this one.
Yeah, absolutely. Great.